Hello. Let's look at the relationship between the coefficients and the roots of a quadratic equation. What is a coefficient? Well, a coefficient is a number or constant used to multiply a variable. So if we have 3x or ky, then 3 and k are the coefficients. What about roots? Well, the roots of a quadratic function are the values of the variable for which the function is equal to 0. So if we have a function in x, so f is the function, x is the variable, and it is equal to x plus 3 all multiplied by x minus 1, in order to find the roots, I have to set the function equal to 0, which means x plus 3 all by x minus 1 is equal to 0, which means that x is either equal to negative 3 or 1. And negative 3 and 1 are the roots of my function. Just for completeness, please note that x plus 3 and x minus 1 would be considered the factors of that function. The standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. I'm sure you've all seen that, where a, b, and c are the coefficients of the quadratic equation. If I divide through by a, I get x squared plus b over a by x plus c over a is equal to 0. And it's important to note that equations 1 and 2 have the same roots. So proceeding with equation 2, suppose I tell you that those real roots are alpha and beta. Well, then what are the factors? It means the factors are x minus alpha and x minus beta, which means that I can rewrite equation 2 as x minus alpha all by x minus beta is equal to 0. If I expand that, I get x squared minus beta x minus alpha x plus alpha beta is equal to 0. Let's neaten that up. I get x squared minus into alpha plus beta by x plus alpha beta is equal to 0. And this is equation 4. So take a look. Ensure you understand. And then we need to note that equations 2 and 4 are identical. They are equal for every value of x. So x squared plus b over a by x plus c over a is identical to x squared minus into alpha plus beta by x plus alpha beta. It is just that the left-hand side is in terms of a, b, and c, and the right-hand side is in terms of alpha and beta. Because these two are identical, it means that I can compare the coefficients of x squared on either side of the identity, the coefficients of x on either side of the identity, and the constants on either side of the identity. So starting with x squared, that's fairly simple. The x squareds are the same. But what about the x's? On my left-hand side, the coefficient of x is plus b over a, whilst the coefficient of x on the right-hand side is minus into alpha plus beta. What about the constant? The constant on the left-hand side is plus c over a, while the constant on the right-hand side is plus alpha beta. I can equate my coefficients. That means that I can say that b over a is equal to negative into alpha plus beta, and c over a is equal to alpha beta. So let's write these with the roots as the subjects of the formula. So I'll have alpha plus beta is equal to negative b over a, and alpha beta is equal to c over a. And you'll note that alpha plus beta is the sum of the roots, while alpha beta is the product of the roots. And this is the crux of my relationship between the coefficients and the roots of a quadratic equation. It means as well that I can rewrite any quadratic equation that was originally of the form x squared plus b over a by x plus c over a in this form: x squared minus the sum of the roots by x plus the product of the roots is equal to 0. And we're going to use this information and see how we can use it. So, example 1. If alpha and beta are the roots of the equation 2x squared minus 5x plus 12 is equal to 0, what is the value of the sum and product of the roots? We know that the sum of the roots is alpha plus beta. The product of the roots is alpha beta. We have a is equal to 2, b is equal to negative 5, and c is equal to 12. So let's use the relationship that we just derived. So the sum of the roots, alpha plus beta, is equal to negative b over a. So that is equal to negative of a negative 5 over 2. And let me take this opportunity to issue my first warning about beware, respect the negative signs. So that is equal to 5 over 2. That's the sum of my roots. What about the product of my roots? Alpha beta is equal to c over a, which in this case is 12 over 2, which is equal to 6. Your turn. Try these two questions, pause the video, and then check the solutions. So, what is the sum and product of the roots for 2x squared plus 12x minus 3? Sum of the roots is equal to negative b over a, which in this case is negative 12 over 2, that's negative 6. And the product of the roots alpha beta is equal to c over a, which is negative 3 over 2. For the second equation, x squared minus 8x plus 5 is equal to 0. The sum of the roots is equal to negative b over a, which is negative of negative 8 over 1, which is 8. And the product of the roots, c over a, is equal to 5. Notice negative, negative. Example 2. Find the equation with roots alpha and beta, where alpha plus beta is equal to 4 and alpha beta is equal to 1/2. The question says find the equation. Well, recall that we can write any quadratic equation in this form. X squared minus the sum of the roots by x plus the product of the roots is equal to 0. We know that the sum of the roots, alpha plus beta, is 4. And the product of the roots, alpha beta, is 1/2. So by simply substituting, we get x squared minus 4x plus 1/2 is equal to 0. While this is correct, generally speaking, what we do is we multiply by a number that would enable us to have integer coefficients. So if we multiply by 2, we would get 2x squared minus 8x plus 1 is equal to 0. We like integer coefficients simply because they're nice and neat. You give it a try. Pause, write out your answers, and then check with the solutions. So here we go. Remember, your equation is of the form x squared minus the sum of the roots by x plus the product of the roots is equal to 0. And we want to watch out for that minus and plus. So, the first question, if the sum of the roots is 4 and the product of the roots is negative 7, the equation is x squared minus 4x minus 7 is equal to 0. For our second question, it would be x squared plus 4x plus 15 is equal to 0. Why plus 4x? We had a negative and a negative. And for the third question, x squared, again two negatives, plus 3/5 x minus 1/2 is equal to 0. I'm going to multiply everything through by 10, and we'll get 10x squared plus 6x minus 5 is equal to 0. Again, we want integer coefficients. Someone might ask, why multiply by 10? Think about it for a second, and you'll realize that 10 is the LCM of 5 and 2. Here's another example of the use of the coefficients roots relationship. The roots of the equation x squared minus 3x plus 4 is equal to 0 are alpha and beta. Without solving the equation, find the value of 1 over alpha beta, x squared plus beta squared, and 1 over alpha plus 1 over beta. So let's look at these in turn. What do we know? Well, we know that the sum of the roots alpha plus beta, which is equal to negative b over a, is equal to 3. And we know that the product of the roots alpha beta, which is equal to c over a, is equal to 4. So we have to use what we know to come up with what the question requires. So let's look at part A. 1 over alpha beta, well, that's pretty straightforward because we know that alpha beta is 4, so 1 over alpha beta is simply 1 over 4. So let's just carry forward what we know. Alpha plus beta is equal to 3 and alpha beta is 4. Part B asks for alpha squared plus beta squared. Now at this point, your brain should start to think about what is alpha plus beta all squared. And you should recall that that is alpha plus beta multiplied by alpha plus beta, which if you use your FOIL and multiply it out, is alpha squared plus 2 alpha beta plus beta squared. With a little rearranging, you see I have my alpha squared plus beta squared. I get alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. So simply substituting for alpha plus beta, I have alpha squared plus beta squared is equal to 3 squared minus 2, and then you substitute for alpha beta, 4. 9 minus 8 is 1. So this here is a pretty useful equation to remember. And as a matter of fact, it's useful enough that here are 2 equations that I'd like you to remember. I suggest you take your time and write them down somewhere and highlight them and refer to them periodically. Alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. And alpha cubed plus beta cubed is equal to alpha plus beta all cubed minus 3 alpha beta all multiplied by alpha plus beta. So let's proceed. Again, what do we know? We know the sum and the product. And we're asked to find 1 over alpha plus 1 over beta. Well, what do we have here? We have the addition of 2 fractions. And remember, as I always tell my classes, fractions are our friends. So what do you do when you want to add 2 fractions? Well, you find the LCM, which in this case is alpha beta. You resolve for the numerator, so that would be beta plus alpha. Of course, I can rewrite that, since addition is commutative, as alpha plus beta over alpha beta, which is simply 3 over 4. You can take your time and go back over those 3 examples and then try these 3 questions on your own. Pause, write them out, and then check the solutions. So for the equation given, you first have to have written down what you know. So you know that the sum of the roots is 5 and the product of the roots is negative 2. So we start off with the addition of 2 fractions. Find the LCM, alpha beta, and the numerator, it's alpha by alpha, which is alpha squared, plus beta by beta, which is beta squared. So I know alpha beta, so I can substitute for that immediately. And I have to remember that alpha squared plus beta squared is equal to alpha plus beta, all squared, minus 2 alpha beta. So when I substitute, I get 5 squared minus 2 multiplied by minus 2, which is equal to 25 plus 4, which is 29. Please use parentheses when doing your substitutions, especially when we have negative signs. It helps to keep you on track and avoid making mistakes. So, to finalize, we have alpha over beta plus beta over alpha is equal to 29 over negative 2. Let's try part B. This question asks for the sum of alpha cubed and beta cubed. Remember, alpha cubed plus beta cubed is equal to alpha plus beta all cubed minus 3 alpha beta into alpha plus beta. So simply substituting, we get 5 cubed minus 3 multiplied by negative 2 multiplied by 5. That's 125 plus 30 is 155. For part 3, we have another sum of fractions, 1 over alpha squared plus 1 over beta squared. So the LCM is alpha squared plus beta squared, and alpha squared beta squared, pardon me, and the numerator is beta squared plus alpha squared, which can be rewritten as alpha squared plus beta squared, all over alpha beta all squared. Again, alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. Substituting the values, and of course we already found out that alpha squared plus beta squared was 29 in the previous question. So our result is 29 over 4. Here's our last example. Find the equation whose roots are 1 over alpha and 1 over beta, where alpha and beta are the roots of the equation 2x squared minus 5x minus 6 is equal to 0. So here you see we have two different equations. We want an equation where the roots are 1 over alpha and 1 over beta, and we have the equation where the roots are alpha and beta. So we know alpha plus beta, which is equal to 5 over 2, and we know alpha beta, the product of the roots, is equal to negative 3. We get that from the equation that we are given. And the equation that we want to find is of the form x squared minus sum of the roots by x plus product of the roots. But in this case, this sum of roots is 1 over alpha plus 1 over beta. And the product is 1 over alpha multiplied by 1 over beta. So to state again what we know alpha plus beta is 5 over 2 and alpha beta is negative 3. And what we need is 1 over alpha plus 1 over beta. And 1 over alpha multiplied by 1 over beta. So we know that 1 over alpha plus 1 over beta, well, that's a fraction. We find the LCM, alpha beta. Our numerator is beta plus alpha, which we can write as alpha plus beta. So we have alpha plus beta all over alpha beta is equal to 5 over 2 over negative 3, which is equal to 5 over negative 6, which we would write as negative 5 over 6. And 1 over alpha multiplied by 1 over beta is 1 over alpha beta, which is equal to 1 over negative 3. And again, we would write that as negative 1 over 3. So, thus, our required equation is x squared minus negative 5 over 6 by x plus negative 1/3 is equal to 0. Well, let's neaten up those double negatives and the plus by the negative, and let's multiply through by 6. And our final equation is 6x squared plus 5x minus 2 is equal to 0. You can replay that example again, ensure that you understand. Of course, we wanted integer coefficients here again. And you try these final two questions. Pause, write them out, and then check the solutions. So for our first one, we have x squared plus 7x minus 2. And we want a new equation with roots alpha squared and beta squared. So we know alpha plus beta is equal to negative 7, and alpha beta is equal to negative 2. Alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta, which is equal to negative 7 all squared minus 2 by minus 2, which is equal to 49 plus 4, which is 53. And alpha squared beta squared is equal to alpha beta all squared, which is negative 2 squared, which is 4. The required equation is x squared minus the sum of the roots by x plus the product of the roots is equal to 0. So we have x squared minus 53x plus 4 is equal to 0. For our second question, we are given the equation x squared plus 5x minus 3, and we want a new equation with roots alpha cubed and beta cubed. So we know the sum, alpha plus beta equal negative b over a, which is negative 5. And the product of the roots alpha beta is equal to c over a, which is negative 3. We need alpha cubed plus beta cubed and alpha cubed beta cubed. Alpha cubed plus beta cubed, remember, is alpha plus beta all cubed minus 3 alpha beta into, or multiplied by rather, alpha plus beta. Do the substitutions, you get negative 5 all cubed minus 3 multiplied by negative 3 multiplied by negative 5, which is negative 125 minus 45, that's minus 170. And alpha cubed beta cubed is, of course, alpha beta all cubed, which is negative 3 cubed, which is negative 27. Thus, the required equation, which is of the form x squared minus the sum of the roots by x plus the product of the roots, is x squared minus by negative 170 by x plus a negative 27, which is x squared plus 170x minus 27 is equal to 0. Well, I trust that that was useful, and that brings us to the end of this video. Thank you.